Okay, so for those of you who need a little bit of extra help, want to see this again, or if you were absent, this is the study guide for 7.2 Quiz 2 with answers and brief explanations. Number 1 says which table represents a proportional relationship. In order to know if it's a proportional relationship, all of these tables have to have the same constant of proportionality. So I need to know what to multiply each of these numbers by to get from x to y. So if I don't know what to multiply 5 by to get 8, 5 times what equals 8? We've talked about how you can use a related fact family, start at the answer 8 and divide by 5. So you can leave it as 8/5, or you can actually do 8 divided by 5 to see what that is, and that gives us 1.6. In order for this to be proportional, then I can check to see, well, is 6 times 1.6 equal to 9.6? 6 times 1.6 is 9.6. So far, so good. Let's see if 10 times 1.6 is equal to 16, which it is. So it looks like this one is the correct answer, but I'm going to check all of them just in case. For B, I want to know what to multiply 5 by to get 25, and I know that that is 5. So I'm going to check to see, is 6 times 5 equal to 36? No, it's not. 6 times 5 is 30, so right off the bat, this is not proportional. Once you know that one of them does not have the same constant of proportionality, you don't have to check any others. And then the next one, let's see, what do we multiply 5 by to get 7? Well, I'm not sure, so I'm going to set it up like this on the bottom, and I'm using a related fact family. Starting with the answer, I would do 7 divided by 5, because division is the opposite of multiply. 7 divided by 5 is 1.4. So now I'm going to check these others and see if it's true. Is 6 times 1.4 equal to 8? No, it's 8.4, so that's no, that is not true. And then for the next one, I'm starting with 5 and 8, which I've already done here. So I know that this is times 1.6, so I can check, is 6 times 1.6 equal to 9.6. No, it is not, so this is not proportional. Also, I could have used this first one again. I already found out that 6 times 1.6 is 9.6. It can't be 9 and 9.6, so I knew that that wasn't going to work out. For number 2, it says to select all of the proportional relationships. I'm just going to wait 1 second because this is auto-focusing and I don't want it to be blurry. There we go. Number 2, all the proportional relationships. The scuba diver sank at a constant rate until he reached the reef. When you hear that something is a constant rate or a steady rate or same pace, those words tell us it is a proportional relationship. For the next one, we have an equation. Y is equal to 4/5 x. Well, we've talked in class that the standard equation for a proportional relationship is y is equal to mx, where m is the constant of proportionality. It does not matter that this number that would be in the same position as m, it doesn't matter that it's a fraction. It is a number multiplied by x to equal y. Therefore, it is a proportional relationship. For the next one, Jessie swam for 5 minutes, floated for 15 minutes, and then swam again. Well, because Jessie is doing one thing for 5 minutes, swimming, and that could be a steady rate, but then when Jessie stopped and then started swimming again, they're not doing the same thing for the whole entire time at the same pace, so this is not a proportional relationship. For the next one, it's another equation. Remember, the standard form of a proportional equation is y is equal to mx, where m is the constant of proportionality. Since this is a number multiplied by x to equal y, this is proportional. And then for the last one, we've got y is equal to 12 divided by x. This is not true. We don't write 12 divided by a number, or 12 number divided by x, I should say. This is not a proportional relationship because it's not y is equal to some number times x. So this is no. For number 3, Sarah is mixing water and food dye to make different colors. When she decides on a recipe, the number of cups of water, W, that are needed for D drops of dye is described by the equation W is equal to 1.5 D. So now, in order to answer these, I can see that there is no table here, And for me, when we list the information in a table, it is much clearer. So the first thing that I'm going to do is set up a table in order to be able to answer these questions a little bit easier. So I'm going to start with here. So I see that the equation given is W is equal to 1.5D. I know that the variables are different, but it is still in the form of Y equals MX. They just substituted W for Y and D for X. So I'm going to put D first because X comes first in the alphabet, and that would typically go here. Then I'm going to put W here because Y would be the second column in the table. And now it tells us that in order to get the value of W, we are multiplying D times 1.5. So going in this direction, I am multiplying by 1.5. So in order to figure out what 1.5 tells us in this situation, and I want to answer in a unit rate with both drops of dye and cups of water, I'm going to put 1 under drops. If I have 1 drop of dye and I multiply that times 1.5, I know that that gives me 1.5. This is a unit rate because I am comparing two different units, the amount of water, cups of water, and drops of dye, and one of these values is a 1. I didn't leave myself very much space to write, so I'm going to write this over here. The unit rate I could write would be 1.5 cups of water for every 1, there's my 1, which I need in a unit rate, drop of dye. There's other ways to say that. You could have said 1.5 cups of water per drop. There's lots of different ways as long as you have both units, cups of water and drops of dye. Those are the units. And one of the numbers is just 1, which here is 1 drop. The next question says, how many cups of water are needed to mix with 8 drops of dye? Well, I'm going to use this table that I said. Of dye. I'm going to put an 8 in drops, and then I'm going to multiply that by our constant of proportionality, 1.5. 8 times 1 is 8. Half of 8, 0.5 times 8 is 4. 8 plus 4 is 12. So I know that that would be 12 cups of water. And then the last question, how many drops of dye are needed to mix with 3 cups of water? So 3 cups of water, I'm going to plug that into my table. And now I'm still going to use the constant of proportionality, but because I'm going the opposite way, I'm not going to multiply 3 times 1.5. I'm going to divide 3 by 1.5, and 3 divided by 1.5 is 2. So I'll put 2 here. That's 2 drops of dye. On the back, it says when you mix 2 colors of paint in equivalent ratios, the result is always the same color. Complete the table so that there is a proportional relationship between cups of green paint and cups of white paint. So first and foremost, I need to look for where there's corresponding numbers so I can see what do we multiply one by to get the other. 7 times 4 is 28. So the constant of proportionality has to be 4. So I'm going to multiply by 4 all throughout to get the values of white. This time, however, though, because it is going the opposite way, I'm not going to multiply by 4. I'm going to divide 52 by 4, and that comes out to be 13. Here we're going back the other way again, so I'll multiply by 4. 10 times 4 is 40. The next part of this question asks, what is the constant of proportionality? Well, I know X comes first in the alphabet, so it would be the first column in the table. Same with Y. What do we multiply X by to get Y? We already figured out that's 4. Complete the unit rate. Blank cups of white paint per cup of green paint. When it says per cup of green paint, that's talking about 1 cup of green. So where I have green paint in this table, there's 1, there's 4 cups of white for every 1, so that is the unit rate. And then lastly, it says write an equation for the relationship between the number of cups of white paint, W, and the number of cups of green paint, G. So I know the standard form of the equation for proportional relationships is y equals mx. So I'm going to start with that, and then I'm going to plug in what I have from this table. Y in this case is white paint, so I'm going to use the variable W. So it's going to be W is equal to M, where M is the constant of proportionality. We figured that was 4. And then 4 times X, but in this case X is green paint, so that's 4G. W is equal to 4G. And then the last problem, number 5, has a bunch of parts to it. It says here that the turtle took 6 minutes to walk 24 inches at a constant pace. Constant pace tells us that it is proportional. Let D represent the distance that the turtle walked, after T minutes. What are 2 different constants of proportionality for the relationship D and T? So in order to figure this out, again, I'm going to go ahead and I'm going to set up a table. So I'm going to come down here where there's some extra space, and I am going to set this up. And I know that I've got the time and the distance that the turtle walked. Those are our 2 variables according to the directions given here. In the information given, it takes 6 minutes to go 24 inches. So I'm going to put 6 minutes, or 6 under the time and minutes, and then 24 inches is a distance. From here I can figure out what we multiply 6 by to get 24. I know that that's 4. So one constant of proportionality is 4. The other constant of proportionality is just its reciprocal. Remember, a reciprocal is writing the number as a fraction and then just flipping the numerator and denominator. So I can even put, okay, that's 4 over 1, a whole number. 4 divided by 1 is 4, so that's how we write it as a 1 over 4. As far as this next question, what is the relationship between the 2 constants of proportionality? Well, I wrote it already one time. I'm going to write the same thing. They are reciprocals. And then this next part says write 2 different equations to represent the relationship between distance, D, and time. Well, I can already use this information to figure out part of it. I know that in order to get the distance, I multiply the time by 4. So that equals the distance. So the first equation, where we have distance equaling something done to T, I'm going to plug in the distance is equal to 4 times the time. Because the distance is bigger, I know it's 4 times as big as the time. When we flip the variable's position, all we have to do is write the other equation using the reciprocal of the constant of proportionality that we already found. And then the last one, if the turtle walked 54 inches at the same rate, how many minutes did it take? So since it's 54 inches, inches is a distance, so I'm going to put that under D. And since I'm going the opposite way, I'm not going to multiply, I'm going to divide by 4. And 54 divided by 4, 54 divided by 4 is 13.5. So it took the turtle 13.5 minutes. Make sure you have units, minutes on your answer. And that is the end of our study guide.